welcome back to my YouTube channel in which I have created playlist of data science covering the basic and advanced concepts. Now my next topic is neural networks. So let's discuss what is neural network. In data science, neural network is a computational model inspired by the way the human brain processes information. It is used to identify patterns, make predictions, and solve complex problems through a process called machine learning. Neural networks are a powerful tool in data science for solving complex problems that involve large amount of data and intricate patterns. Now let's discuss what are the components of neural network. First, neurons. These are the basic units or nodes in the network, analogous to neurons in the human brain. Each neuron receives input, process it, and pass the result to the next layer of neuron. Second is layers. Input layer, the first layer where the data is fed into the network. Each neuron in this layer represents a feature of data. Second is hidden layer. Layers between the input and output layers, where the actual computation happens. A neural network can have multiple hidden layers, which is why deep learning models are sometimes called deep neural networks. Third is output layer, the final layer that produces a prediction or classification result. Now the next component is weight and biases. Each connection between neurons has a weight that controls the importance of the connection. There is also a bias term that allows the model to adjust the output along with the weights. These weights and biases are learned and adjusted during the training process. Next is activation function. After each neuron computes a weighted sum of its input, an activation function is applied to introduce non-linearity into the model. This helps the network learn complex patterns. Next, the optimization. Gradient descent is most commonly used to minimize the loss by adjusting the weights in the network, aiming to improve the accuracy of predictions. Now, let's discuss what the types of neural network. First is feed-forward neural network, FFN. FNN, the simplest type where data moves in one direction from input to output. Second is convolutional neural network, CNN, specialized for image data using convolutional layers to detect patterns like edges, textures, etc. Third is recurrent neural network, designed for sequence data such as time series or natural language, where the output depends on previous inputs. Last, generative adversarial networks consist of two neural networks that work against each other to generate new synthetic data. Now let's discuss what are the areas where neural network is used in data science. First, image and video recognition. Neural networks, especially CNN, are used in facial recognition, object detection, and image classification. Second, anomaly detection. Neural networks can identify outliers and or unusual patterns in data. Third is natural language processing, NLP. RNN and transformers are widely used in speech recognition, language translation, and sentiment analysis. Fourth, predictive modeling. They are used to make predictions in finance, healthcare, and other industries based on historical data. Now, let's move to the coding part. Here I have provided the code to demonstrate the neural networks application using Python. First, import package that is NumPy pandas with the alias name nppd, and then import necessary libraries like load iris to read iris dataset, train test split to perform splitting, standard scalar, sequential, dense to categorical to accuracy scope. In order to read iris dataset, I have load iris and stored the result in iris variable. In order to read the features, I have used iris.data and stored the result in y variable. In order to label the data, I have used iris.target and stored the result in y. Then we will perform the preprocess the data. We will use standard scalar function to perform the task and store the result in scalar. And then we will use scalar.fit transform method to normalize the features using standard scalar. And then we will convert the labels to one hot encoding by using two categorical function and then store the result in by one hot variable. Then we will perform splitting by using train test split function. Then we will build a neural network model by using sequential function and then store the result in model variable. And then we will perform different processes to create a input layer, hidden layer, output layer, and by using the add function. And then we will compile the model by using compile method. And at last we will move to the next process, that is the train the model by using model.fit function. And then we will evaluate the model on the test data by using model.evaluate function, and then we will store the result in test accuracy, test loss variables, and then we will make predictions on the basis of the result which we got above. And then we will convert one-hot predictions to class labels by using np.argument_max and np.argument_max variable. So this was all about neural networks. Thank you for listening patiently and happily.